Welcome everyone. In this video, we'll take a look at two A-level chemistry multiple choice questions. In the first question, we have to balance a chemical equation. In the second question, we need to assign oxidation states in order to identify a reducing agent. Details are in the description and also at the end of the video. Let's get started. Here's the question. In the balanced equation, what is the mole ratio for sulfuric acid to water? Get out of the habit of balancing for individual atoms when you have to balance equations. There are 4 sulfate ions, SO42- on the right hand side of the equation, so there must be 4 sulfate ions on the left hand side. Next, balance for hydrogen or oxygen. Hydrogen works out to be a little bit more straightforward for this question. There are 14 hydrogen atoms on the left. There must be 7 molecules of water on the right in order to balance for hydrogen. The answer is option C, 4 to 7. Here's the next question. What is the reducing agent in this reaction? And it's the same reaction. To address this question, we need to use oxidation states to find out what is oxidized and what is reduced. It is important to memorize the rules and guides for assigning oxidation states. Group 1 metals, such as potassium, will have an oxidation state of +1. The oxidation state of potassium does not change in this reaction, so we can reject option C. Post in the comments if you can think of an example of when the oxidation state of potassium is 0. In most compounds, hydrogen has an oxidation state of +1. The oxidation states for hydrogen and potassium are above each of these symbols in the balanced equation. The oxidation state of hydrogen does not change in this reaction, and we can reject option A. Once again, post in the comments if you can think of an example of when the oxidation state of hydrogen is -1. Sulfate is common to both sides here and has the formula SO4 2-. Oxygen has an oxidation state of -2 in each of the compounds here. We need to work out the oxidation state of the chromium and carbon containing species in the reactants and products. It is helpful to know that the dichromate ion is Cr2O7 2- and the ethane dioate ion is C2O4 2-. I have put -2 above each oxygen atom in the equation to represent the oxidation state. Next, we will work out the oxidation state of carbon in the ethane dioate ion, C2O4 2-. Because the oxidation state of oxygen is -2 here, the total negative charge from the 4 oxygen atoms is given by -2 multiplied by 4, which is -8. The sum of the oxidation states in a species is equal to the overall charge on the species. There must be a +6 charge coming from the 2 carbon atoms. +6 minus 8 equals -2, where -2 is the overall charge on the ethane dioate ion. Because the +6 charge comes from 2 carbon atoms, each carbon atom must have an oxidation state of +3. I have added the oxidation state of carbon in ethane dioate above the ion in the overall equation. The total negative charge from the 2 oxygen atoms is given by -2 multiplied by 2, which is equal to -4. The sum of the oxidation states in a species is equal to the overall charge on the species. Carbon dioxide is neutral, so the positive charge from the carbon atom must be +4. The oxidation state of carbon in carbon dioxide is also +4. The oxidation state of carbon increases from +3 in C2O4 2- to +4 in CO2. Oxidizing agents bring about or facilitate oxidation. Oxidizing agents are themselves reduced. Reducing agents, on the other hand, facilitate reduction and are oxidized. The answer must therefore be option B. We can check by working out the oxidation state of chromium in the reactants and products. The oxidation state of oxygen in the dichromate ion is -2. The total negative charge from the 7 oxygen atoms in the dichromate ion is -2 multiplied by 7, which is equal to -14. -14 plus 12 is equal to -2. -2 is the overall charge on the species here. The +12 charge comes from the 2 chromium atoms, so each chromium atom must have an oxidation state of +6. Let's look at chromium sulfate next. Remember, the sum of the oxidation states in a species is equal to the overall charge on the species. The sulfate ion is SO4 2-. If we split the chromium sulfate up into its constituent ions, there must be 3 sulfate ions, giving a total negative charge of -6, and 2 chromium ions, giving a total positive charge of +6 because chromium sulfate is neutral. Each chromium ion in chromium sulfate must therefore have an oxidation state of +3. It is not possible to have reduction without oxidation and vice versa. The oxidation state of chromium decreases from +6 in potassium dichromate to +3 in chromium sulfate. Potassium dichromate is reduced, therefore potassium dichromate is the oxidizing agent. Potassium dichromate is quite a common oxidizing agent and is used in the oxidation of primary and secondary alcohols. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.